Right, good morning. KA6 Benzene and phenol. Quick run through of the answers and any pointers I want to make. So, question one, equation for the reaction of benzene with chlorine. If you're writing equations for these organic substances, use displayed or structural formulae. Don't just use the molecular formulae, okay? So really, I don't know, you should really know this. This is the most basic equation of benzene, really. How does this happen? As we know, benzene is not very reactive. So the halogen carrier allows the Cl plus to form because it wouldn't form just by because the electrons are so spread out over the ring. There isn't enough electron density to cause a dipole in a chlorine molecule. So you need the halogen carrier to form the Cl plus, or whichever halogen it is, the electrophile basically. Mechanism, you just have to learn these mechanisms. I'm surprised at how many of you didn't get this right. And secondly, I cannot stress again, curly arrows must come from a bond or from electrons or from a lone pair to a positive charge. If you don't do that, you just don't get the mark. So, I can't make it any more clear, I don't think. And lots of you don't show the especially this curly arrow coming from the hydrogen bond, replacing the electrons in the ring. You're not showing it in the right place. Okay, the product here is H plus, not HCl, because the other Cl is up here, isn't it? Yeah, it's in AlCl4. So when you're drawing this equation, you just put H plus. Okay, called electrophilic substitution. Okay, because we're substituting a hydrogen. All right, then you're asked for this one to compare the reaction of an alkene with bromine and benzene and bromine. So, ask yourself this thing here, at the beginning, before you start to write your answer. What have they got that's the same? Yeah, but how do they behave differently? So they've both got pi electrons. Benzene's electrons are delocalized over the ring, so they're very spread out, so the electron density is less. The alkenes, it's localized between the two carbon atoms. So the electron density is greater in alkenes, hence can attract an electrophile more easily and can also create an electrophile from a neutral molecule like Cl2, which benzene can't. Okay, question 2. This is about nitration. So you're given an equation here, and OH is a 2,4 directing group. So if you're going to suggest another organic product, as far as I'm concerned, this is the only one you've got. In the mark scheme, it does say 3-nitrophenol, but I'm not sure how 3-nitrophenol would occur. So as it's a 2,4 directing group. So I would just go for that. Remember your directing groups. And I don't know, everyone seems to have lost their brains. Maybe 2 people got this right, as if they've forgotten how to work out a percentage yield, which is pretty basic stuff, I have to say, and go back to the AS year. I think we did this in the very first part of the year, September, October time. This is how I've done it. It's not specifically done like this in the mark scheme, but I find this the easiest way. If you're given the grams of something, work out how many moles, look at the ratio in the equation. So if you had 100% of this being formed, how many moles would be 106? Convert that back to grams and then find 27% of it. Okay, so again, saying the same thing over and over again, please go over your AS stuff. You should be going over it constantly now. Your exam is not far away, and the more you can review the AS year, the better it will be for you. Okay, yeah, this is a rates of reaction question thrown in just for good measure, just to make sure that you're still remembering the A2 stuff that we've already covered as well. So there's your rate equation, there's your chemical equation. I asked you to calculate K, so it's just basically rearranging. I'm putting these, they've given the values here for the concentrations and they've given you the rate. And the units, obviously we've got 3 lots of moles per dm cubed at the bottom, 1 at the top. So we're left with 2 on the bottom. So reciprocal, so it's to moles to minus 2, dm to 6, and seconds to the minus 1. Calculate the initial rate of the experiment if it's repeated under the same conditions but with double concentration. So I don't know why this seemed to confuse a lot of you. And when they say initial rate, they're just saying rate. That's what they're saying. That's how this is calculated. Yeah. So you just doubled the concentrations. Don't forget that you need to square that value. Apart from that, pretty straightforward. It's only 1 mark. Yeah, some of you have forgotten, obviously, that the rate equation gives you the rate determining step. So here we've got 2 NOs. In our rate equations, NO squared, which means we need 2 NO, and we need H2. So here's H2, here's your 2 NOs, so that must be 2 NO here, 2 NO, and so on. Okay, I talked a little bit about the importance of benzene in terms of making drugs. So most of you should have been able to at least put down drugs or pharmaceuticals here, and some of you did get other uses as well. I admit I haven't specifically gone through the uses of the reactions of benzene, but that's the kind of thing that I would expect you to be when you're reading around the subject to pick up, really. Okay, nitration of benzene, you learn these conditions, has to be concentrated acids, and the temperature must be, I was always taught 50 degrees or less, but Mark scheme says 50 to 60 degrees, so I think you'd be alright as long as you wrote something like that. Okay, balanced equation for the nitration of benzene, so I've drawn it using the structural and displayed formula. Pretty straightforward, to be honest. And then you're given a mechanism, which makes it nice and easy. You don't even have to draw the mechanism. Explain what a curly arrow represents. A lot of you didn't recognise that it's a pair of electrons moving. It's got to be a pair of electrons if it's got the double-headed arrow moving to form a covalent bond, or breaking a bond in some instances. Why is this an electrophile? Really, you need to know the definitions. You know, an electrophile, electron pair acceptor. So obviously NO2 plus is accepting a pair of electrons from benzene, because it does say as an electrophile in this mechanism. Why is it substitution? Pretty straightforward here. We're substituting hydrogen by NO2 plus or NO2. And then how do we know that sulfuric acid is acting as a catalyst? It's because it's not in the equation and it is regenerated. Okay, yeah, this is calling on some AS knowledge here, really. We looked at iodine, halogen bonds back in AS when we were looking at hydrolysis. Iodine, bromine, iodobromide. If some of you, made the statement bromine is more electronegative, and then went on to say that it would form the electrophile, which doesn't make sense. So think about what you're writing when you're writing it. If it's more electronegative, the electrons are going to form Br minus, which is going to leave I plus, and then you're going to form iodobenzene. Okay, and here's the equation that you can expect to see. Okay, so there we are. We're looking at, in this case, acylation, isn't it? An acyl chloride. Okay, reaction of an aromat with an acyl chloride, reaction of an aldehyde with hydrogen cyanide. Okay, So this one, 5 marks, and you make sure that you actually cover all the points that are asked for here. Yeah, write an equation. That's the first thing. I've just drawn it out here so that it makes it clear why you have to write your structural formula like this. If you didn't write it like this, you didn't get the mark, you know, because you have to show the arrangement of atoms, which you invariably do with organic molecules, because they can be arranged in lots of different ways. You need to make it absolutely clear how they're arranged to use structural formula or displayed formula. In this case, I would use structural formula. The name, phenol propanone, because this is the propanone bit, phenol as in benzene ring. The catalyst, identify the catalyst, it's AlCl3 because we need a halogen carrier. Yeah. Form, then it says identify, show how the catalyst is used to form a reactive intermediate. So this is your reactive intermediate, yeah, CH3, CH2, CO plus. And then obviously that will then go on and react with benzene because it's got a full positive charge. It needs a full positive charge. And then how the catalyst is reformed. Your H plus comes off the benzene and takes the chlorine from the halogen carrier. Okay, and there's your 5 marks. But, you know, just make sure there's quite a lot asked for up here, and a lot of you missed out, say, the name, or they didn't write the catalyst, and so on and so forth. So just make sure you have covered everything. So here we're showing the mechanism of the reactive intermediate. Yeah, with a positive charge. Again, the electrons are coming from the ring to the positive charge, from the bond to the ring. Make sure that you've got your kind of horseshoe with the positive charges pointing towards where your intermediate has joined benzene, and then your final product. And the name of the mechanism here. Okay, so now we're looking at propanal, which is a carbonyl group, yeah, with HCN. So propanal, write an equation, you know. I mean, again, use structural formula. So we've got alcohol group joining on, and then carbon and the nitrogen, yeah. So 2-hydroxybutane-nitrile, because we've now got 4 carbons, and we've got our alcohol group on the second carbon. This is because it's a carbonyl group, it's a double bond being broken and added across. It's an addition reaction, and in this case we've got CN is a nucleophile. It's being attracted to the positive charge in the carbon. Okay, so the outline, the mechanism. Don't forget, please put lone pairs and the minus charge. You must have the minus charge. The electrons, you've got your positive and negative charge distribution in your carbonyl group. So your electrons are attracted to the positive. Then the electrons, carbon can't make 5 bonds. So the electrons in the double bond hop onto the oxygen, leaving it with a full minus charge. It's got this pair of electrons, lone pair here. And we have H plus come in to form the alcohol. Okay, it comes generally from water or acid. Okay, so there's your final. It's a straightforward mechanism, which you need to learn these basic mechanisms. You know, the electrophilic substitution, the nucleophilic addition, and so on. And you can apply. They should be able to apply them then to any situation. Okay, and then this one is, you know, asking you really to think a little bit about what you know. You know, you're applying knowledge. Rate determining step involves attack by the nucleophile. Yeah, so that CN coming in is the rate determining step. How quickly does that happen? How will the rate of propanone compare with the rate of reaction of propanal? So again, this is going to be. I'm surprised how many of you didn't recognise that propanal is going to react faster, because the aldehyde group is on the end, Yeah, so if you just scribbled them out, you know, in a test or in an exam, just you'd see straight away that the positive carbon is much more available in the aldehyde than it is in the ketone. But you need to explain to get the marks. So again, they've both got carbonyl group. One of them, the ketone, is in the centre of the molecule. You can talk about stabilisation from the alkyl groups on either side. Obviously, they're electron donating. They also cause steric hindrance, so they get in the way of the incoming nucleophile. So hence, it's just generally going to make it more difficult for propanone to react, whereas propanol, the carbonyl is on the end of the molecule, and it's pretty easy for the incoming nucleophile. And then make, you know, the final statement that propanol will react faster, or you could have said it at the top and then gone on to explain why. Okay, so that's it. Not too bad, I didn't think, although I will talk to you about it in class. Okay, bye.